Hey everyone! Today, we're diving into the world of home experiments that are super fun and interactive. So grab your lab coats, or an old t-shirt, and let's get started. Let's kick things off with the classic baking soda and vinegar volcano. Build your volcano with modeling clay around a bottle or just use the bottle. Dump a few tablespoons of baking soda into the bottle opening. Add a few drops of food coloring for a colorful eruption. Slowly pour vinegar into the bottle and watch your volcano come to life. Ever seen an egg bounce? This experiment turns an ordinary egg into a bouncy wonder. Place a raw egg in a jar and submerge it in vinegar. Let it sit for 24 to 48 hours. After its vinegar bath, carefully remove and rinse the egg. The eggshell will have disappeared, leaving a rubbery texture. Go ahead, give it a gentle bounce. Time to get messy with oobleck, a substance that defies physics. Oobleck is a fascinating material that behaves in ways that seem to contradict the laws of nature. It's a simple mixture, but its properties are anything but ordinary. Let's dive into the world of non-Newtonian fluids and see what makes oobleck so special. To make oobleck, start by mixing 2 parts cornstarch with 1 part water in a bowl. This combination is the key to creating the unique properties of oobleck. As you mix, you'll notice the texture changing. It might seem like a simple science experiment, but there's a lot happening on a molecular level. Stir the mixture until you get a gooey, thick consistency. The more you stir, the more you'll see the transformation. The cornstarch particles are suspended in the water, creating a substance that can act like both a solid and a liquid. This is where the magic of oobleck starts to show. For an extra touch of fun, add a few drops of food coloring to your mixture. This not only makes the oobleck more visually appealing but also adds an element of creativity to the experiment. Watch as the colors swirl and blend, making your oobleck unique. Now comes the fun part, playing with your oobleck. Poke, squeeze, and apply pressure to it. You'll notice that it feels solid when you apply force but flows like a liquid when you release the pressure. This is because oobleck is a non-Newtonian fluid, meaning its viscosity changes under stress. Oobleck is a non-Newtonian fluid, behaving as both a solid and a liquid. This unique property is due to the cornstarch particles being suspended in water. When you apply pressure, the particles lock together, making it feel solid. When you release the pressure, the particles move freely, allowing it to flow like a liquid. This simple experiment is a great way to explore the fascinating world of physics and chemistry. Skittles aren't just delicious, they create a mesmerizing rainbow effect. Arrange Skittles in a circle on a plate. Pour warm water into the center, touching the Skittles. Watch as the colors dissolve and create a stunning rainbow pattern. It's a mini art project and science lesson in one. Impress your friends with this simple but cool trick. Fill a bowl with water and sprinkle pepper on the surface. Dip your finger in dish soap. Touch the water's surface and the pepper scatters to the edges. The soap disrupts the water's surface tension, causing the pepper to move. It's all about surface tension. We're making a DIY lava lamp. Fill a clear bottle halfway with water and add food coloring. Pour in vegetable oil until the bottle is almost full. Drop an Alka-Seltzer tablet into the bottle. Watch as colorful blobs rise and fall, mimicking a lava lamp. The tablet releases gas, creating bubbles that carry the colored water up. Harness the power of static electricity with a balloon. Rub a blown-up balloon against a wool sweater or your hair. Hold the charged balloon near lightweight objects like paper or hair. Watch as they jump towards the balloon, demonstrating static electricity. Witness the power of capillary action. This simple yet fascinating experiment will show you how water can seemingly defy gravity and move from one place to another without any external force. It's a perfect demonstration of the wonders of science that you can easily do at home or in the classroom. Start by filling 2 glasses with colored water. You can use food coloring to make the water more vibrant and easier to observe. Leave a 3rd glass empty. The colors will help you see the movement of water more clearly and make the experiment more visually appealing. Next, fold paper towels into strips. These strips will act as the bridge for the water to travel. Place one end of each strip into the glasses with colored water and the other end into the empty glass. Make sure the paper towels are long enough to reach the bottom of each glass. Now, observe closely. You'll start to see the colored water moving up the paper towels. This process is called capillary action, where water molecules are attracted to the fibers of the paper towel and move upward against gravity. It's the same phenomenon that allows plants to draw water from their roots to their leaves. This is capillary action in action. It's a captivating sight, especially for young scientists. Watching the water move and mix colors can spark curiosity and a love for learning about the natural world. The water molecules climb up the paper towel fibers, pulling more water along. This chain reaction continues until the water levels in the glasses equalize. It's a beautiful example of how even the smallest forces in nature can create significant effects. Over time, you'll notice the empty glass filling up with colored water. The colors may even blend, creating new shades. This experiment not only demonstrates capillary action, but also shows how different colors mix, adding an artistic element to the scientific process. Discuss the results with your friends or classmates. Why do you think the water moved the way it did? How does this relate to what you've learned about plants and their ability to transport water? Engaging in discussions can deepen your understanding and make the learning experience more interactive. Finally, take a moment to appreciate the beauty of the experiment. The vibrant colors and the movement of water are not just scientifically interesting but also visually stunning. This simple experiment is a wonderful way to explore the principles of capillary action and the wonders of the natural world. Create a giant foaming fountain with this experiment. Mix hydrogen peroxide, dish soap, and food coloring in a bottle. Dissolve yeast in warm water in a separate cup. Pour the yeast mixture into the bottle and stand back. The mixture erupts into a giant foam fountain due to the rapid breakdown of hydrogen peroxide. Send secret messages like a spy with invisible ink. Use lemon juice or vinegar as your ink. Write a message on paper with a cotton swab and let it dry. Hold the paper near a heat source to reveal the message. The heat oxidizes the ink, making it visible. It's a science-powered disappearing act in reverse. Create a swirling spectacle of color with milk. Pour milk into a shallow dish and add drops of food coloring. Dip a cotton swab in dish soap and touch the milk's surface. Watch the colors explode and swirl. The soap disrupts the milk's surface tension, creating a mini abstract art masterpiece. Build balloon-powered cars for a thrilling race. Use a plastic bottle or cardboard for the car's base. Attach bottle caps for wheels. Tape a straw to a balloon and attach it to the car. Blow up the balloon, hold the end closed, and set the car down. Release the balloon and watch the car zoom across the floor. Explore buoyancy and density with this experiment. Fill a glass with water and place an egg in it. It sinks. Gradually add salt to the water, stirring until it dissolves. Watch as the egg slowly rises. The salt increases the water's density, making the egg float. It's like magic, but with science. Create a dancing ghost with static electricity. Cut a tissue paper into a ghost shape and draw a face. Rub a balloon against your hair to create static electricity. Hold the balloon near the ghost and watch it dance and float. Turn dirty water clean with a homemade water filter. This simple yet effective project can be done with materials you likely already have at home. It's a great way to understand the basics of water filtration and the importance of clean water. Start by cutting off the bottom of a plastic bottle. This will serve as the opening where you'll pour the dirty water. Make sure to flip the bottle upside down so that the neck of the bottle is pointing downwards. This will allow the water to flow through the filter materials and out the neck. Next, layer the inside of the bottle with cotton balls, sand, gravel, and charcoal. Each of these materials plays a crucial role in the filtration process. The cotton balls act as a preliminary filter, catching larger particles. The sand and gravel further filter out smaller particles, while the charcoal helps to remove impurities and improve the taste of the water. Now pour the dirty water into the top of the filter. As the water travels through each layer, it gets progressively cleaner. This process mimics how natural water filtration works in the environment, where water passes through various layers of soil and rock. Watch closely as the water drips through the layers. You can see the transformation happening right before your eyes. The impurities are left behind in the different layers, and the water that comes out is much cleaner than what you started with. The clean water collects at the bottom of the bottle. This water is significantly cleaner and safer to use. While it may not be perfectly pure, it's a great demonstration of how filtration can improve water quality. This simple demonstration of water filtration is not only educational, but also practical. It shows how easy it can be to create a basic water filter using everyday materials. Understanding this process is crucial, especially in situations where access to clean water is limited. So give it a try and see the difference for yourself. Use red cabbage to create a color-changing extravaganza. Boil chopped red cabbage in water to create purple cabbage juice. Pour the juice into several clear glasses. Add different household liquids to each glass. Watch as the juice changes color based on the liquid's pH level. It's a chemistry-powered color show. Thanks for watching. I hope you enjoyed these fun home experiments. Don't forget to like, subscribe, and share your experiment results in the comments below. See you next time.